Hello, this is Jason Straight with the PaaS Cloud Virtual Chapter. Tonight we have Tim Radney here for a presentation on Azure SQL Database for the production DBA. Tim is a SQL Server MVP. He's presented at PaaS, SQL Intersections, SQL Saturdays, user groups, and numerous webinars. He comes from us from Georgia, and he's an all-around great guy. And apparently he also raises dwarf Nigerian goats, which I actually should have asked him a bit about because that's actually kind of interesting. So he'll be presenting tonight on Azure SQL Database for the production DBA. Just to get some announcements, get through some announcements here real quick. We do have some upcoming webcasts in the next few weeks. We've got two from Dave DeVarney coming up in July and then also in September. Those will be covering Azure Data Catalog and Azure Data Factory. And then we've got a presentation with Jared Zegelbaum that's going to be on Azure Active Directory. We're going to be doing that at 12 p.m. Central Time, but we need to modify the date here because we have a scheduling conflict on that. If you are interested in presenting to the user group, please reach out. You can reach us at cloudvc@sqlpass.org. To cover a few PaaS community announcements, we do have the PaaS Summit coming up here in just a couple months. If you are looking at getting a discount on that and you don't have a discount already, you can use VC15C HB6, and that'll get you a $150 discount on your registration. The price for attending PaaS is increasing this coming Sunday, going up to $21.95. So if you are planning to save a little bit of money on it, it would be a good idea to get registered this week. PaaS is quite a large quite a large conference with 200 plus technical sessions and lots of industry experts speaking. The PaaS virtual chapters, there are quite a number of them, like this cloud one that you are attending tonight, but there are others that cover hybrid technologies. There's others that cover database administration, professional development, performance, or if you're looking for something within your own language, if you're not a native English speaker, there's Portuguese, Russian, Spanish, and numerous others. So if there is things that you're looking at getting training on when it comes to SQL Server, the virtual chapters are a good way to find that information. The virtual chapters cover things from doing baselines, which is coming up on the DBA fundamentals here next week, learning to use PowerShell, Power BI, or the Women in Technology has a SSRS 2016 one coming up here in just a few weeks. So there is quite a bit of community training that you can get through the PaaS organization, through the PaaS virtual chapters. Along with virtual chapters, there are SQL Saturdays. SQL Saturdays are one of the coolest things that are part of the PaaS community, the ability to get together with a bunch of people, well, a bunch of your peers, and learn about SQL Saturday for free. Well, learn about SQL Server on a Saturday for free. They occur all over the world, from the US and Canada to Asia to Latin America. If you want to go down to Sao Paulo or you are in the area, you can catch a full day of training down there on October 8th. So check those out at sqlsaturday.com. And as I always mention, PaaS is always looking for volunteers. So if you are interested in volunteering for PaaS, you can go out to volunteer.sqlpass.org and fill out the volunteer information there and help with this community-driven organization. With that, I'm going to turn things over to Tim. And so let me change the presenter. If I can do this the right way. There we go. And so for the rest of the presentation, and for the rest of the webinar tonight, it will be Tim Radney, and he'll be talking about Azure SQL Database for the production DBA. It is all yours now, Tim.
Thank you so much, Jason. And yeah, anytime you want to talk about those dwarf Nigerian goats, let me know. I also have a lot of chickens and raised tilapia, and I have 2 Scottish Highland cows that are currently living on my neighbor's property because they kind of escaped out of mine. So it's been a cow hunt for the past few weeks, but hopefully I'll have them back soon. So while what we're all here for is Azure SQL Database for the production DBA. And where this topic kind of came to be is Many of us a few years back when Azure was kind of mentioned, we got concerned. It's okay, how is this going to make my job change? Is it going to eliminate me as a production DBA if my organization decides to put all our data in the cloud? So I started looking at the product, digging in once it became really kind of enterprise ready and a really a product that enterprises could look at and with confidence decide to move their data assets into it. So as I started going through, it's like, okay, how is this going to change? And that's where this session came to be. So we'll get started. If I can advance my slide. So I am with SQL Skills. We are a team of world-renowned SQL Server experts. I actually like to say that my team is, and then there's me. So I get to work with Paul Randall, Kimberly Tripp, Glenn Berry, Jonathan Cahias, Aaron Stellato. Incredible people. Absolutely love my team. We do instructor-led training. I know a lot of you have probably come out and attended our events. We've taught in the US, the UK, Australia, Ireland, all over. We also do a lot of online training through Pluralsight. We do consulting, which is kind of where I came in. We're doing health checks, hardware, performance upgrades, anything related to the core engine we work with, even dabble with reporting services and integration services, kind of stuff to help organizations that have it deployed. We do remote DBA, which covers system monitoring and troubleshooting. As Jason stated, we present at conferences such as the PASS Summit and SQL Intersection, which SQL Intersection is also coming up toward the end of October. If you're interested in SQL Server as well as possibly .NET, SharePoint, it's a much more broad conference, and there'll be a lot of us there presenting. And kind of the takeaway here is if you're not a SQL Skills insider, I encourage you to go to sqlskills.com/. Paul sends out a bi-weekly newsletter, has some cool stuff about SQL Server, things that are going on within the teams. We include a SQL Skills Insider video with a how-to tip and trick, so anywhere from a 3 to maybe an 8-minute video. So those are really cool. And then if you're an insider, usually toward the end of the year, Paul will send out a list of all the videos cumulative that you can go back out and watch. So I encourage you to do that. I mentioned our immersion events. We have a few more classes coming up this year in Chicago and Bellevue. So we have classes from the Junior Accidental DBA to 2 separate weeks of performance tuning. One of my favorite classes is the HADR. We also do business intelligence. Just recently adopted one for the data science, for SSIS. So lots of classes that you can take a look at sqlskills.com/training. So again, who am I? What do I do? So I'm a consultant, speaker, trainer, and author. I do a bunch of stuff within SQL Server, but the bottom part, I'm into electronics, aquaponics. I farm chickens, goats, cows, and tilapia if I can get my cows back. And I do run the Columbus, Georgia SQL Server Users Group, and we have a SQL Saturday coming up August 27th. So any of you close to Columbus, Georgia, come on down. I mentioned Pluralsight. This is a fun one. So you can email Paul at sqlskills.com. Put user group Pluralsight Code in the subject line or just Pluralsight Code, something. And although he's on vacation, he's still checking email for the next week or so. So make him do a little bit of work. Email him. He'll send you a code. It's good for a 30-day trial of all of the SQL Skills content on Pluralsight, which is over 144 hours. We have 40-plus courses out there already. Mine on consolidation tactics and best practices should be going live in the next few days. Aaron Stellato has a new one that should also be made available in the coming days on Query Store, which I'll talk about more during the session. So email Paul, get the code, 30 days, no credit card required, absolutely free. Check it out, and I promise you, you'll want to start subscribing because there's so much content and training out there. So on to the actual course. What am I going to cover? So first, it's kind of difficult to talk about Azure SQL Database without explaining what it is. And then I'm going to dive into the features, and there's a lot of them. Then I'm going to cover some of the unsupported features, which unfortunately, there's a lot of those too. Then I'm going to do several demos. I'm going to show you how to create an Azure SQL Database. I'm going to talk about the DTU Calculator, which will make sense once I start talking about the features, so database transaction unit. And then I'm going to start talking about the tuning differences. So this is where things change for us as production DBAs used to the box version, the on-premises version. and we're going to talk about some of the tuning options that we have available to us, and then I'll end by going over some tuning, some demos on tuning options, show you some of the approaches that I've taken, how I got started with it, and then we'll wrap up the session. So to get started, what is Azure SQL Database? So Azure SQL Database is a database as a service. I know that's kind of a buzzword, everything as a service. You have infrastructure as a service, software as a service. So with Azure SQL Database, Microsoft has installed the SQL engine. So they have a bunch of virtual machines running. There's SQL Server instances out there, and then you get a container, and your databases go within that container. And those containers are kind of like a server, but it's really like your portion of an instance in your databases. So we don't have TempDB and things like that. You just have your database that's running in a container protected on that instance of SQL. So it's truly SQL Server as a service. So SQL Database is a cloud relational database service. We get predictable performance and pricing. So if you go in and your server is 100 DTU, you know that you have that type of bandwidth and performance that's available to you, and it has a set price. So you know as you need to increase or you need to grow what performance level you're going to get and what price model that's going to come with. There's also Elastic Database Pool for those unpredictable workloads, which I'll explain more, but right now think of Elastic Database Pool as a pool of DTU that can be shared amongst multiple Azure SQL databases. Built in even to the basic model or the basic pricing tier is 99.99% availability. You get that built in. It's just there. That's difficult to achieve in your local data center. I mean, that only allows for a very short time per year of downtime. Built into your standard and premium tiers, you have geo-replication, and then all the tiers have restore services for data protection. It supports existing SQL Server tools, libraries, and APIs. So a lot of things that we have today just work when you turn around and point them to an Azure SQL database. Think of SQL Server Management Studio. It works with Azure. You can scale with no downtime, and there's a lot of security built into Azure SQL Database, so it's secure and compliant for that sensitive data. So what are some of the features? As a production DBA, the most critical thing to me are backups and the ability to be able to restore. So probably more the being able to restore than the backups. But when I started looking at Azure SQL Database, one of the first things that I wanted to look at is what is the backup methodology? How am I going to back up my databases? What are my options for restoring and potential data loss and those sorts of things? And what shocked me was I really can't schedule my backups. I'm not responsible for that. That's done on the back end for me. I can choose to export data, but that's not really your backup. So the backups are handled for you, and we as the production DBA are responsible for the restores. So if you turn your data to mush, you run an update statement without a where clause, and all client names or last names are now straight, then how do you get that back? You have to restore. So when you do this restore, it's going to create a brand new database. So it's a side-by-side, which kind of complicates some things in some ways, but with basic you have 7 days for your backup or your retention history. Your standard tier comes with 14 days and your premium is 35 days. But that gives you point-in-time restore for the entire retention period. So even with the basic tier, you can go back to any point in time within the past 7 days. With premium, any point in time within the past 35 days. So if you knew that you ran that update statement 5 minutes ago, restore up to just before the 5-minute time period, your database is there with all of your data, and then you can choose either to rename the current production database to something else and then rename the restored copy to the production name, let your clients reconnect or restart your application server, and then everything's back the way it was. Or you can choose if the issue wasn't that bad and you just need to update a particular table or a particular value, then you can choose with the restored copy to update the value based on, write your own T-SQL statement, and then you can go and drop or delete the restored database. Now, why I said that it's kind of problematic where you're restoring a full copy of your database, it's a new database, is if I'm running in a say a service tier that's $500 a month, running a P2 or something like that. When I restore my database, am I going to restore it to the same tier? Now, depending on database size, I may have to, and you'll see that on a slide later, but whatever service tier I have to restore it to, I'm paying for that database because it's a new Azure SQL database. So you don't want to restore a copy and leave it out there for a month. You want to restore, do what you have to do, and then get rid of that database because it's going to be costing. And all of the slides are going to include a URL for additional information about the feature that I'm talking about. So I'm going to cover kind of the high points of it, and then for more information you can go and read the additional documentation. So additional features, getting into some of the security aspects, and some of these features we now have with SQL Server 2016 since it was released on June 1st. So dynamic data masking, this can limit access to sensitive data by controlling how the data appears. Now some of you may have gone through in your current life and had to work on masking data in an existing on-premise database, and that requires for you to, in most cases, duplicate the data in another table where it's masked and then have some kind of lookup or translation table, and it's somewhat complicated to achieve that, and then the data is still there in the database in both forms, taking up additional space and so forth. With Azure SQL Database, you choose the column that you want to mask, and then you choose any of the built-in kind of algorithms or the definitions. So if it's account number and you only want to show the last 4 digits, you can choose last 4 digits for this column, and when that data is accessed, it's going to be masked except for the last 4 digits. And it's literally just click the buttons and set it. So these masking rules are predefined, and you can set those on particular columns. And with this, there's no physical changes to the actual data. So if your customers or your users are limited within the application of viewing the data, or they're limited to SQL Server reporting services or something like that, views where they can't write the T-SQL themselves, this works great. Now, if they can write T-SQL, there are some ways to circumvent the data masking aspect, but for the most part, if your users are using an application or they're using reporting services, this is a way to prevent them from being able to do a data dump and having access to people's full account numbers or other sensitive data. And then there's row-level security. So this is where you can restrict access to individual rows based upon a user's identity. So for this, think about your organization. If you have employees that do business with your company and external customers, you may not want employees to be able to look up other employees' data. So if you had a table that had employee status, you could go through and set employee status equals 1. So employees that you don't want accessing employee data, or if there's a particular group, you can set that group that they can't access particular data where employee status equals 1. So for them, based upon the user's identity, you can restrict what access or what data they can see within a table. And this is, again, set at the database level, so it's not something complicated you have to build into the application tier. It's literally rules defined. You can go and choose the row-level security, set the group that has access to all data, and set the group that has access to the restricted data, and the logic based behind the restriction. So if employee status equals 1, they can't see it. If last name equals Radney or straight, they can't see it. So it's really a slick and cool tool, and it's very simple to implement. And it's on the fly. So as soon as you implement it, within a few minutes, it takes effect. So fun stuff. Still on the security aspect, we have always encrypted. This one, to me, is going to be a game changer because other levels of encryption that I've seen, the DBA still have access to the plain text data. With this, it allows the clients to encrypt the sensitive data inside the client applications and not reveal the encryption key to the database engine. So the data is encrypted with an encryption key that the application server holds. It's not at the database level or at the engine level. And so that data never appears as plain text inside SQL Server. It's encrypted. So only your client applications or application servers that have access to those keys can then decrypt and view that plain text data. These encryption keys can be stored or are stored in the Azure Key Vault. So this is really kind of brilliant that you have key management software built into Azure. So you have the Azure Key Vault where you can store these encryption keys. The application servers have those keys. The database engine does not. So the data is securely stored within the engine, and your app servers or your web servers are decrypting the data. It's pretty slick. And I'm really looking forward to, in the coming weeks, getting this installed, playing around with it, seeing ways to try to circumvent it and see how well it does, and then also to look at any performance implications or things. But from what I've read and from what I've seen, I mean, it works well. It's pretty simple to set up, and it's pretty secure. And it's really kind of a lot better than, in some aspects, than TDE or some of the other third-party tools that are out there. You also still have transparent data encryption. We've seen this for several iterations of SQL Server. So with TDE, this is real-time encryption and decryption of the database, your backups, and your transaction logs at rest. It encrypts the storage of the entire database by using a symmetric key. So unlike always encrypted, where you can encrypt certain portions of the database, TDE will encrypt the entire database at rest. Currently, Azure SQL Database does not support Azure Key Vault management or integration with TDE, so you still have to manage that outside of the Azure Key Vault. So we've talked about backups and how they're handled for you. We've covered multiple new security features, so you can see why security and compliance is kind of a big deal for Azure SQL Database, especially since it's in somebody else's data center and on shared hardware and so forth. So there's definitely ways to protect beyond just the Azure SQL Database container structures. So cool stuff. But to me, one of the biggest selling features of Azure SQL Database is geo-replication. This is available in standard and premium tiers, but in the premium tiers, you get active geo-replication. With your standard, it's standard geo-replication. So what geo-replication does is it provides a replica database, so a secondary in a different region. So think about like with always on and how you have a readable secondary or a secondary sitting there ready to be failed over to. So mirroring or versus the availability group with a readable secondary. So if you have the active geo-replication, it's readable secondaries, which is kind of cool. And what you can do with that is if you have your readable secondary in another geographical region where you have employees that need read-only access, they could be reading your readable secondary while your primary is closer to where the work is actually happening. And the readable secondary can also act as your DR. Even with the standard, you have a warm standby built into the product, built into your pricing tier. All you have to do is enable the geo-replication and choose where you want it to go. With the estimated recovery time, which is your ERT, is less than 30 seconds. That's impressive. And you have a recovery point objective of less than 1 hour. Now, of course, the less than 1 hour sounds like a big number, but if you don't have a whole lot of data change and things going on, that replication's still pretty quick, and you can go and play with it. When I've done it, I mean, I've lost no data. I mean, I would do a transaction, I would go and try to generate a failover, and go look at my data, and the transaction that I just did was still there. But that less than 1 hour is some protection and for Microsoft and Azure. So it's less than that, but plan your SLAs around the published numbers. Now, I talked about elastic database pools in the summary or the introduction slide. This is a really big feature. I definitely see if you have more than a single Azure SQL database that you're probably going to want to leverage the elastic database pools. So this is a pool of resources. So it's got a new name. So it's not just a DTU, it's an elastic DTU, so an eDTU. So with this, individual databases can auto-scale within a set of parameters. So let's do some math and some hypotheticals. Let's say that you have 10 databases or 10 Azure SQL databases, and on average, they need to consume 50 DTU. So 10 databases, 50 DTU each is 500 DTU. Well, 500 DTU, on your normal workload, it's 50, but you can see that some things start running slow. They could better perform if they could scale up to, let's say, 100 DTU. Well, 10 databases, 100 DTU. Now you're at 1,000 DTU. Do you want to set all the servers at 100 DTU so that they can bump up to that for an hour a day at different times and pay that extra cost, when on average they're all consuming 500? Well, what you could do is switch over from individual Azure SQL databases in their pricing tier, choose to use Elastic Database Pool, and maybe you choose a number like 700 or 800, something less than 1,000 but it's more than 500, and you set a limit that each one of these can't consume more than 100 DTU. So if one of them went errant and started consuming 500 DTU, it's not going to cause everyone else to suffer. So you can basically set a govern that those 10 databases can't consume more than 100 DTU, even though you only have 800 available as a pool. So if any of them need the extra resources, they can scale up temporarily from their 50 to the 100, do that request, and then idle back down. So what this allows you to do is, under that heavy load, a database can consume more eDTUs to meet demand. So here in the United States, it's easy for us to think about your cable modem. So your cable provider says speeds up to X, so up to 100 gigabit or up to gigabit. And you can run your bandwidth test, and you see that if nobody else is on the internet, you can achieve that gigabit. But when everybody's home and they're streaming Netflix and everything, your bandwidth is more realistically around 70 gigabits or 70 megabits, something substantially less. But maybe your provider says, we guarantee you, 25 gigabit would burst up to a terabit. It's kind of like that with the Elastic Database pools. So you have a pool, but you can set reservations, you can set those limits, the parameters that they can't go above, and it allows you to really simplify provisioning all these databases by using the Elastic Database pools, especially if you're like a software as a service and every one of your customers gets a new database. So you can have this big pool. As you start consuming more, say if we went with 1,000 eDTU, and on average we're using 800, and then our workload's increasing, we're seeing we're now averaging 900, maybe we want to then scale up to a 1,200, kind of thing. So it definitely helps you be able to monitor your overall usage and then add as your business grows without having to micromanage dozens or hundreds of individual Azure SQL databases. So to me, that's going to be a big feature for those that need scalable performance and have a lot of databases. And for those of you who have been using in-memory, in-memory is supported for Azure SQL Database in the premium tier. So you have memory optimized tables which are represented in active memory. And there's a bit.ly link here for additional information. This particular feature has been changing slightly over the course of since Azure SQL Database has been out. As things change within the infrastructure, we're seeing that the sizes are continuing to grow. So effective in different dates, we've seen certain P levels increase where before it was 2 gigabits, or now move up to 4 and so forth. So just be aware of that. I've yet to see anything go down. It's usually you're getting more for your dollar than prior. So the biggest feature within SQL Server 2016 that has been available in Azure SQL Database for a while is the query store. So this is your black box recorder for SQL Server. Really, really slick feature. Again, I mentioned Aaron Stellato has a Pluralsight course coming out. I'm chomping at the bit for when it releases to get to go watch it and learn more about this feature so I can start demoing it and playing with it myself. But this provides detailed historical information about all of your queries. So it enables you to easily identify queries that are performing poorly because it keeps a history of each query, including its associated plans, the runtime, statistics, and information about the resource consumption. And what I've read and seen with Query Store is it's so challenging for us when we're doing performance tuning to try to find when a particular plan or query chooses a different execution plan and what that tipping point is. And with Query Store, that's being tracked for you. So you can dive in and figure out why a particular query may choose one plan over the other and see what you can do to tune the query so that it chooses the right plan each time, or pass it hints or create additional indexes. I mean, so much information is being kept that you can now go and dive into. And the thing about Query Store is this is database level feature. So you have to turn it on per database that you want to have this feature on. And then also there's some fine tuning that you can do on the Query Store in reference to how much space it's going to take up, which isn't a whole lot, and how long it's going to retain the data for. Do you really want 12 months worth of Query Store data? Probably not. So you may want to tune so you keep a certain amount and that it's not consuming more than however many hundreds of megabytes that you want to allocate for it. And tying in with the Query Store, you have the Index Advisor. Now the Index Advisor is much more than your missing index DMV or running Database Tuning Advisor. From what I've read about Index Advisor and talking to some of the folks within Microsoft, is this thing is using some machine learning technology to determine where potential indexes could improve query performance. So anytime I hear the machine learning and the data analytics and things that are going on and the amount of data that's being collected with Query Store and how they can analyze, I'm probably going to pay attention to this feature and dig into it. And that's why I'm kind of waiting to get some of these production clients in Azure SQL Database so I can start looking at some of these features against real workloads rather than just things that I can generate using mocked up databases and AdventureWorks and things. I want to see this in the real world and see this stuff in action. So I definitely see Query Store and Index Advisor being game changers for what we do. So is our job as production DBAs going to be negatively impacted? No. Our skills of having to performance tune and getting back to making queries just run better rather than throwing hardware at it is going to become keen and extremely important. And Microsoft is giving us the tools to do that with Query Store and Index Advisor. So I talked a lot about the features. I mean, we're now at 30 minutes after the hour, so we have just under 30 minutes more to go. So with all the features, I mean, that's some rich stuff, things that are going to make our life better and easier. But what are some of the things that we're used to with the box version of SQL Server that are missing or not supported within Azure? Now the first thing that jumped out at me is there's no SQL Server agent. And nothing that I have read or talked to or seen in real life shows me that my index fragmentation is being taken care of for me, or that my statistics updates are being taken care of for me, or any of those other things that I want to do. So how are we as DBAs going to handle scheduling these types of tasks? Well, the easiest thing is you can use a current on-premises SQL Server, connect to your Azure SQL Database, and run those jobs. Because Azure SQL Database is nothing more within SQL Server or SSIS or SSRS than a data store. So it's just another data source, so you can connect to it and run your jobs against it. But do you really want that to be on an on-premise? If you already have a MSDN account or you're leveraging Azure, why not spin up a very small Azure virtual machine, have it run SQL Server, and then run your jobs there. So you can have a centralized SQL Server running on a VM that's managing all of your Azure virtual machines for your other index or your maintenance operations, any of your ETL that you need to do. So that's definitely an option. And then I've heard of some third-party tools that are coming out to handle scheduling within the cloud. So those would probably be pretty advantageous to do as well. However, if you're like me, control and you're fairly free, I mean, use an existing on-premises or a very inexpensive virtual machine. there's no database mail. So that one, it's like, okay, if I don't have jobs failing because there's no SQL Server agent, okay, I might be okay with that. But there's no events, event notifications, and query notifications. You can't run a SQL Server trace or profiler in Azure SQL Database. There's no trace flags. So for those of us who are used to installing and configuring SQL Server, I mean, we can't set up event notifications. We can't turn on trace flags for certain performance things that we need. Why? I mean, why are those things not supported? Well, if we stop and think about it, I mean, a trace flag is instance level. Profiler and trace run at the instance level. You have to go in and specify which database if you just want to run it on, capture a trace against a particular database. So with Azure SQL Database, we're not responsible for the engine. So anything instance related or engine related is going to be shut off for us. I mean, we're truly just looking at our container in our respective database. So anything that would be an instance level change can't do. If there's not a SQL Server agent and database mail, I mean, there's no integration services. There's no button to choose to be able to handle your ETL. So how would you do that? Well, again, integration services running on premises or on a virtual machine in Azure. So you can set up integration services and reporting services and those things and just have them connect to your Azure SQL Database. So pretty easy to still set that up and manage. There's no log shipping, database mirroring, or transactional replication. But remember, we have geo-replication that's built into standard and premium. And there's a lot more, getting into some of the syntax related things and other features. I just wanted to list some of the top ones that I saw that were very impactful for the production DBA, the guy or girl that's responsible for installing and configuring and managing SQL Server. What would we expect to see? Now, some of the other things, I mean, you can run the, there's a wizard, a tool. I know Aaron Bertrand has written a blog post on it. I should include a bit.ly link for it, where you can run the advisor against your database to see if Azure SQL Database would support it. And anything that's not supported, it gives you recommendations and so forth. So there's certain things that, just syntax that you may have to go and change. There's certain data types that are not supported. So those things you may or may not be able to modify your existing database to make work. So we'll switch over to one of my virtual machines, and I'll step you through how to create an Azure SQL database. Pretty simple, and I'll show some of the things that kind of stood out to me on what's different between creating one on my local instance versus within Azure. And then while we're there, we'll go ahead and switch over and we'll talk about the DTU Calculator. Now, you heard me talk about DTUs and eDTUs, and there's also stretch DTU, which if you're using stretch database, so there's a whole other DTU value, and I recently wrote an article for SQLperformance.com on getting started with SQL Server 2016 RTM and stretch, and I'm truly shocked at the pricing for the stretch DTU, which you can read up on that. And today I just saw a post that went out that showed me that the values, the price that I mentioned in the article was actually a 50% discount. So it's actually double. And I want to say for the lowest value, the 100 SDTU or stretch DTU was like $980 or $960 a month, but it's actually $1,860 a month for the basic smallest stretch DTU that you can get, which, wow, I mean, that's a large number to be paying per month. All right, so we'll connect over to my virtual machine. Let me find which one I was running. So we'll start, everyone should be able to see my SQL Server Management Studio. I'm connected to a couple of instances. One is my local instance running on this virtual machine, and then I'm connected to my Azure container, which is a funky name, YENKEWIB08. I just took one of the defaults and then realized I could have named it, which I probably should go back. So we're in the instance. Most things within Azure you'll do within the portal. There's some things you can do within Management Studio, and then a lot of the administration you can get into managing using PowerShell. So if you're not a PowerShell guru, there's Pluralsight courses for that, or you can use the portal. But anything that you're going to be scripting and doing repetitive, highly advised to automate some of those things using PowerShell. So if this is the first time you're seeing the Azure Portal, your home screen or your dashboard are tiles. So much like the Windows Phone and Windows 10 and things, you can move things around on the tiles or on your dashboard. You can add additional things. So this is just the standard. There's a couple of objects I recently went in and deleted, so it's kind of showing some failures there. But one of the things I like to look at is the service health. So if I click on this, you'll see all of the Azure data stores or data centers, and they're showing green. So currently all Azure data centers are in good health. If there was a problem with one, it may turn yellow. If one was down for whatever reason or beyond a certain capacity, it would turn red. So that's kind of neat. To get started with something new, you can choose to click New, and this is going to give you the entire market space. So do I want to create a new virtual machine? Do I want to create a new hybrid integration? Do I want to create a new container? And then I can start typing that I want to create a new SQL database. So I can choose SQL database here, but I've also got SQL databases listed here. So I can go into SQL databases on the left under my menu, and you'll see that I have AdventureWorks, AdventureWorks 2, and then a database called Speaking Events. So my Speaking Events is where I track all the user groups and SQL Saturdays and conferences and things that I speak at, the date, the session, and various tidbits of information. So if I wanted to create a new database, I could click Add, and it's going to bring up a window. And the options that I can give it is a name. So we'll call this one Pass Cloud. And then I have to choose my subscription. Now, I have two. So if you're a consultant and you're managing multiple subscriptions for different clients, or your organization has different accounts for different lines of business, then you'd want to choose the proper subscription. So I have Visual Studio Enterprise and one under BizSpark. So I'll keep it under BizSpark, and then you can create a new resource group, or you can choose an existing. So I'll stick with the South Central US. You can choose a source, so either a blank database, so it'll just create the shell, and then you can go and run your script to create your schema. You can choose sample, which is a version of AdventureWorks, so we'll keep it blank. You can choose your server, so this is where I can keep it on my current container, the YENKEWIB, or I can choose to go and create a new server. So they call it server, but it's really a container. So I'll keep it on my existing, and then this is your pricing tier. So it's going to default, or mine's defaulting to S2 standard. S2 standard is around, I think, $50 a month. So it's 50 DTU. The pricing is loading, so it has to go and check. So $75 a month for an S2. I don't want to use up my MSDN subscription credits by spinning up a $75 a month server for a demo. So I'm going to choose basic, which is $5 a month. So for a minimum of $4.99, you can get 99.99% uptime, up to 2 gigabytes of space, and that comes with 5 DTUs, which is kind of okay for a single user just inserting and deleting data. Your next step up is going to be to a S0, which is a 10 DTU, but this gives you geo-replication and up to a 250 gig database. $15 a month really isn't that expensive, even coming out of a personal budget for your own benefit in storing your data. I mean, maybe you want to store all your music files, inventory and movies and things like that. So $15 a month for 250 gig and geo-replication. And that can support a couple of users in a production type environment. And then you just start stepping on up. So your standards go up to S3, which is 100 DTU, and then you step up to a P1 at 125. So now you're getting into a P1, 500 gig of storage, 125 DTU up to 1750 DTU in that premium. And the P11 also comes up to a terabyte of storage, and these give you the active geo-replication versus your standard up to $150 a month for 100 DTU. And 100 DTUs, that's a pretty good amount. And you'll see when we run the DTU Calculator in the next demo some of these values and workloads and what that means. So we'll stick with the basic, and then I can change my correlation. and then I click create, and my database gets created. So what are some of the things that you see that you're kind of used to when you're creating a database that we don't have an option here? I can't choose my database file names. I can't choose multiple files. I can't choose their placement. I can't choose their default size, their auto growth size. All that is handled on the back end. I can choose the name of my database, the correlation, and basically where it gets stored and the performance level. That's about it. So if I click create, then it will go and start provisioning that database. From within Management Studio, I can right click and say new database, and my options are create database, the database name. And I can choose the service S0, so standard and S0. So my pricing tier and the name are what I can choose when I'm just using the basic create database. So if we refresh here, we'll see that our past cloud database has now been provisioned. And if we go back to the portal, we can refresh, and we have our past cloud database. So kind of neat. So another option is if I have a local database. So on my local instance, I have my speaking events database. Sometimes people come up, and one of the things they want to know is how can I get my database from my on-premises version up to the cloud? Can I back up and restore it? No. I wish we could. I wish there was a simple way of backing up my database, restoring it, and then porting it over into Azure. We can use SQL Server integration services to script and move everything. We can use T-SQL to script and move everything. One of the easiest ways for a smaller database where you can kind of take that outage is to right-click and go to Task. And then I want to export data tier application. I'll click Next, and it's going to prompt me for a path and file. So I'm going to call this Past Cloud, and since we already created one called Past Cloud, a database, we're going to call this one too, just for the naming convention. And then we'll click Finish, and this is going to go out and it's going to kind of review the schema, make sure everything passes for the Azure database, and then it just created my backpack. So it created a backpack file. I can go up to Databases and choose Import Data Tier Application. Choose Next. I'm going to browse out to the file that we just created, Past Cloud 2. You can also, if I exported to my Azure Blob storage, then I could connect to that container. So this is a way you can export and go ahead and have the file exported into Azure so that your import is much quicker. But your export is going to take a while longer because you have to push it initially up to the cloud. So we'll choose Next, and it's going to default, the edition. I have Standard, Basic, Premium. If I want to do Basic, so maximum 2 GB size. Service objective is the Basic. Database name's Past Cloud 2. Choose Next. It's going to interrogate my file and then prompt me for the import. So while that's thinking, okay, it's already there. So we'll click Finish, and so now it's going to import that database. And we'll take a look at that again in just a moment. But I want to go ahead and switch over to the second demo and start talking about DTU. So how many DTUs do you need? How many? This says throughput units. It's actually been changed. So I guess two different groups were trying to come up with the name of what DTU stood for. So it's either database throughput unit or database transaction unit. I've been told to refer to it as a transaction unit, so that's what we're going to go with. So how many database transaction units does your local database need for the pricing tier? Do I need 100 DTU? Do I need 1,000 DTU? That's a game changer if you're going to be spending $500 a month or if you're going to be spending $7,000 a month. I kind of want to know what I'm looking at. Give me a ballpark figure. It's kind of like how much memory does my SQL Server need? Well, as much as you can give it. So this gives us a method to get an idea. And so what the DTU Calculator is a script. It's a PowerShell script. Has a couple of things that it's doing. We can see here that it's capturing the processor, the logical disk writes, reads, and the database log bytes flush per second. So you run this tool. It's going to collect this information about your particular database, the one that you specify, and then you can type in the number of cores that was ran against, and then upload the file, and then it will calculate and give you an idea of what DTU that during the time that script ran, what you would need to perform the same. So with this, we'll take a look at 3 different files that I've collected from different workloads, and these were production workloads that I ran this against. So we'll take a look at one of the files, and we see the time that it was captured, the date and time, and then the values. So this kind of goes through and has everything listed from the writes, the reads, the log flushes, and so forth. Now the script itself, we'll take a look at. It's the PowerShell script. Take a look at the edit. And we'll see that it's pretty well documented, telling you what it's stepping through and doing, but I want to scroll down to the areas that we can change. So by default, the max samples was 3,600. So I changed mine to only run for a minute versus an hour. You'll notice that under the processor time or the logical disk, we have disk reads per second and disk writes per second, and then that repeats. So if you have a data file on one line and a log file on another, you can specify C for your data file, D for your log file, or vice versa. Since on my machine, everything is, I just have a C drive, it's a virtual machine, and then I set both to C. And then you can change where the file is going to write to. So I had mine write to Azure SQL perfmon log.csv, and again I set it to run for 60 seconds versus 3,600. So what you would want to do in production is to make sure that when you run this, you run it long enough and during a normal workload, and you may want to run it multiple times throughout the day, morning, afternoon, and evening. But you want to make sure that you run it long enough to capture your standard production workload and your heaviest usage. You don't run it during a maintenance window when nobody's doing anything and say that, hey, we can run on a S0, when in reality you need a P4. So since I've ran this on a few workloads, we'll go and upload and take a look at a 2 CPU, 8 CPU, and a 4 CPU machine and see what these came back with. So we'll start with one that was just a small 2 vCPU machine. We upload and we see that 94.92% of the workload that was ran during that time, and I did run this for an hour on these clients, came back in a basic tier. So this particular client, if they only needed 7 days worth of backup, they could run on a $4.99 server. There was literally no workload. Now personally I would tell them to spend $15 a month and get the standard, or the S0, so they have geo-replication and 14 days worth of backups. I think they could afford it. But we see that we had one little spike that bumped up to 125 DTU, but it was such a short period of time that for the most part, this server sat within a 5 DTU threshold. There's only 5% that exceeded out of that hour time that was beyond a basic. So we'll go back and we'll take a look at a larger machine, and this was a pretty heavily utilized machine for one of my clients. Had 4 virtual CPU, and I want to say it had 16 gig of RAM. This one came back as an S3. Now an S3 is your 100 DTU, but we can see they spiked up to 250 during different times. But almost 92% fell within an S3. So could this client run successfully and without complaints on an S3 server at 100 DTU? Quite possible, but they might want to step up to the P1 to get to 125. I definitely don't think they need a 250 because they're going to pay for that bandwidth and not really use it. So this is where, if this particular client with the 3 different machines using some elastic database pooling could come in handy. So from 100 DTU, they needed 5 on the other. Let's take a look and see what their largest machine that was running 8 vCPU, again a big beefy box. I believe this one had 64 gig of RAM, and this came back and said a P4. Now with a P4 is 500 DTU. So maybe this particular client could bump up to a 750 so that this workload has plenty of room to go. They set it to a 600 DTU limit. They set their S0 to 150 limit, and then the basic one, a 25 limit, and see how they perform, rather than spending 500 DTU on this one, 125 or so on the other. And then as their workloads increase, they can continue to tune or increase the workload or the pricing tier. So in this case, I would probably spend some time, because now this customer is getting into some dollars with a P4, is to look and say, are there things that we can tune, or is this really just a heavily used machine? So DTU Calculator, very simple to run, very easy to read. You import the file, gives you that starting point. But again, the key takeaway here is to run this workload or the calculation over your busiest time so that you get a true reading. And we'll switch over back to the Management Studio, and we'll see that this database was then uploaded. So that was our Cloud 2. So we'll refresh, and we'll see the past Cloud 2 database. So if we take a look back in Management Studio, and we'll see that we exported the Speaking Events database. Look at tables, we have a DBO events. The past Cloud 2 has appeared. We expand tables, and we have our DBO events table. So we just took an on-premises database on my local virtual machine in Fortson, Georgia, and uploaded it to the South Central Azure region as a Azure SQL database, and only took a few minutes to do. Now again, it's a small database, but you see how simple the process was to step through. So we're going to come back over to our PowerPoint. So we talked about, or I showed you how to create an Azure SQL database, even how to migrate an Azure database, and then the DTU Calculator. So what are some of the tuning differences? We have instance level settings that we can't change, which for us instance guys is challenging at times. So there's no temp DB that we can modify. You can't change the cost threshold for parallelism or the max degree of parallelism. Min and max server memory are off limits. We can't change those. You can't enable optimize for ad hoc workloads. Pretty much anything requiring SP configure and reconfigure we can't do. Global temp tables are not supported, and you cannot run DBCC free proc cache. So those of us that tune a lot, that's our job. We're used to being able to free the procedure cache to be able to go in and tell what's new coming in and how to do things, and we can't do that with Azure SQL Database. Global temp tables, I found this by using Paul Randall's file stats over time and wait stats over time. He was using a global temp table to capture some of the data and then capturing the delta and comparing the differences, and we can't do global temp tables because we only have access to our container. So I had to make some changes. So tuning options, the easiest thing to do, we kind of stepped through some of this, was upgrading the tier. So this is a in-place, no outage to be able to migrate from a basic to a standard or standard to a premium. So if we started off and we were running that workload on an S3 and it was just too slow, we could move to a P1, see how that makes any changes. When we go to a P1, we get active geo-replication, we get a larger scale database, we get in-memory OLT support, we can handle more, well, I guess from an S3 to a P1, your max sessions and things are different, but from an S2 to a P1, you get increases to concurrent login requests and so forth. So there's more than just performance impacts between the tiers. So if your database is 500 gigabytes, but you only need 20 DTU, what you're going to have, or excuse me, if it's over 250 gig, you're going to have to get rid of data, or you're going to have to pay for the premium tier. So performance reasons, point-in-time recovery reasons, standard versus active geo-replication are all factors to know to have to move to a higher tier. It's performance. So with performance having to move to another tier, we truly have to know that our workloads are tuned the best, because now it's going to impact the wallet. To move from a standard to premium is dollars. And then we get to the old school. So it's more and more important for us to be able to tune and fix bad queries, because moving to those higher DTU tiers costs money, versus when we had it on premise, a virtual machine, you could easily ask for more vCPU or more memory, and kind of mask the performance issue with more horsepower. That was almost a free upgrade. You could just put in a service request and get those things done without having to provide a cost center. With Azure SQL Database, it's more present that we have tuning options, or if it's truly, you can show that the workload has increased, which hopefully means the cash flow positive has increased. To make more money costs more money, so you may truly need that workload. But for tuning, what are things that we can do? I still rely on the file statistics and file statistics over time to be able to look and see which of my databases are being impacted. Am I currently suffering from writes or reads? Because we know with writes, we can tune and get rid of duplicate indexes. We can try to get rid of unused indexes, but outside of that, it's an I/O subsystem issue. And with that, we may have to move to a higher performance tier if there's just so much write data going on. If it's a lot of reads, then I can start looking at my high-cost queries, my long-running queries, my high CPU queries, those types of things, and start tuning. So with the file statistics, if you're like me and you've been used to using Paul's script for the examining I/O subsystem latencies, sysmaster files does not exist. So I had to modify that to use sys databases. And like I mentioned, global temp tables. So in the capturing I/O latencies over a period of time, I had to modify from a global temp table to a local, and then I changed the local temp tables, since they're referenced differently than global, I changed it to check by using the object ID because the naming standards are different between global and local. And I have all that documented on a SQL performance article. With weight statistics, there's a change. Your OS weight stats contains weights for the entire container that your database is in, not just your respective database. So with that, there's a new DMV, sysdmdb weight stats, which are for the specific database that you're running the script in. So that's where you probably want to look more at. You're still kind of concerned with the overall container if you're running multiple databases like I am. But Paul's script works for both. You just change from OS to DB, and the script runs, and it still excludes all those benign weights. And same issue with the weights over a period of time. You want to change OS to DB, and then I had the same issue with the global temp tables. But every bit of that is documented in the Getting Started Tuning Performance in Azure SQL Database on SQLperformance.com, which I included the bit.ly link. So with that, I have one final demo. Then we'll come back and I'll summarize and tell you everything that we just talked about. But I do just a quick little demo. It's overly simplistic. Paul's standard script, if I try to run it, it's going to come back and fail saying sysmaster files does not exist. So I could go and change sysmaster files to sys databases, and then the references to MF for the master files I would need to update and change, and there's a pretty standard simple stuff. Just kind of step through the errors or read the article. So with this, I'm going to, if I take a look at current I/O latencies, this is since my server has been up, or my database has been up. So I don't know with these read latencies and write latencies, is that current? Is it something that just happened? I want to know right now. Users are complaining, so what is my current write latency and read latency? So to do that, I would need Paul's script for the I/O latencies over a period of time. Then I'm going to have this run for 1 minute. And while that's running, I'm going to also capture for 1 minute the weight statistics. And the demo that I'm going to run, I'm just going to select from a couple of tables or for particular values. Then I'm going to look through it a few times so that we can come back and run a script and see the use counts. And I have that up right now. If you're one of the methods of tuning, I mean, everybody has their approach, and it's kind of a fine art for each person. I mean, you can start by looking at your high-cost queries based on CPU, based on disk I/O. And both of those approaches are great, and I do those. But one of the things I like to do if I'm tuning a server and they're not necessarily complaining about a particular query or things, I like to look at the most used execution plans. So which queries are being reran and reused the most? Because if I can find a query that's been running for 4 seconds and it's executed 100,000 times a day, and I can turn that into a sub-millisecond query, I just made a substantial impact to that server without necessarily looking for the highest disk I/O or highest CPU, because usually those are pretty gnarly scripts that are thousands of lines of code and views calling views and functions and procedures. And so an approach I like is looking at the use counts and starting there, and then kind of branching out into the disk and CPU. So with this, I tend to like to free the procedure cache, because on a production system this can be thousands and thousands of records. But if I try to run DBCC free proc cache, it tells me I don't have permission, I can't do this, because that would free it for, a lot of DBCC commands aren't supported. And with 2016, Glenn Berry has been doing a lot of research and came back because I asked the team about this. And he said, oh, well, there's all these new scoped configuration options that you can do for a particular database. And so we have an altered database scoped configuration, and you can clear procedure cache. So if we clear the procedure cache that way and we take a look, then my sysdm exec cache plans got wiped out, and the SQL text, and I mean, it freed the procedure cache for this particular database. So that's pretty cool. So we're going to execute these two scripts, but I'm going to go ahead and kick off the waits over time, the file stats over time, and then we'll execute these scripts, and it's just going to loop quite a few times over. And while that's running, let's go take a look back at the portal. We'll take a look at the AdventureWorks 2 database, and we can see our resource utilization. Well, we could have seen it. It's telling me no data available. I'll switch between two and see if we can come back. All right, well, no options there. Well, let's go into the pricing tier. So we see that currently I'm running as an S0 with 10 DTU. If I wanted to step up to say 20 DTUs at $30 a month, I could choose this and then say select, and then over the course of a few minutes my instance would be migrated from S0 to an S1. And so basically under the covers, Resource Governor is being used to restrict and limit my consumption of the resources. So all they're doing is increasing from one Resource Governor level to another to allow me to spend from 10 DTU to 20 DTU, which is kind of cool. So we'll come back. This has completed successfully. We take a look at our waits over time. Why do I not have any results? All right, so we'll look at latencies. So on our latencies, we see that my read latency was 9 and my write latency was 3 for my data file. And for my log file, my write latency was 8. So not really anything substantially bad going on with this particular workload. But if we take a look back at my script, we'll see that we had a particular query that was executed 50 times. So if we take a look at that query and we want to look at the actual execution plan, oh, my index was already there. So I did this demo a week ago, or excuse me, 2 days ago, and forgot to clean up my query. So we take a look at the execution plan and we see that we have a table scan. So with the table scan, we know in tuning that we just scan the entire table, that we're missing an index, and it even gives the missing index impact in the recommendation. So an impact of 99.9%. That's pretty substantial. So if we create that non-clustered index, we should be able to turn this estimated subtree cost from 5.269 to something much less. So we'll go ahead and create the index. And that's probably going to take a minute, so we'll go back into the portal and look around at a few more things. So I'm kind of disappointed that the resource utilization did not come up and show the DTU in use, because that's usually pretty nice to be able to look at and see what's going on at that time. And I'll tell you that SQL Sentry, I believe it was version 10 of their product that came out, includes Azure support where it monitors your DTU usage, and then you can get detailed information and monitoring and be able to know that either I've chosen way too high of a DTU asset, or that I'm really kind of pushing my limits and particular queries and workloads are being constrained because I only have a certain DTU and could benefit from a a higher volume. And tools like that can capture that information and log it for you is going to be beneficial to be able to monitor and manage these workloads. Because as you could see, I mean, no data available, and saying that my database hasn't logged into it for 10 minutes. So I guess it's showing you past history and not current. So we'll go back. Our index has been created. So we'll rerun that same query. We'll capture the execution plan. We see we now have an index seek, and our estimated subtree cost is now 0.0057. So it went from over 5 to 0.005. So back to how is my job as a production DBA going to change? Well, you're going to have to fine-tune tuning is basically it. The managing of the Azure SQL databases, managing the DTUs, managing your workload, making sure that you're staying ahead of any workload increases and performance issues are going to be more critical than they are today, because most of us in the on-premises big data centers, virtualization, big hardware, utilizing things like Cisco UCS, those products and solid-state storage and things, we're able to mask so many coding issues with hardware. Now we're going to have to pay for those resources and pay pretty substantially. So tuning the workloads and making sure that we're not introducing new stored procedures that aren't indexed properly and things are going to be more critical. Doing the UAT testing and performance testing are going to be mission critical. So what we covered, discussed, what is Azure SQL Database, and it's database as a service. We talked about all the features, from the security features and the backups being taken for you. You're responsible for the restores, from query store and index advisor, geo-replication. I mean, really, really neat things. We talked about some things that we can't do, like database mail and SQL Server agent and integration services, and how we can circumvent a lot of those features that we don't have. I showed you how easy it is to create an Azure SQL database, and we even migrated one from my local virtual machine up to the cloud. I showed you how you can calculate a starting point for your DTU utilization. We went over tuning differences and some tuning options, such as fixing queries, as well as just migrating to a higher DTU server. And then I ended with showing a pretty simplistic tuning method, how we're still responsible for those indexes and making sure that things are running properly. So with that, I want to say thank you all for giving of your time tonight to get an introduction to Azure SQL Database. I hope you've learned something new. I hope that it eliminated any fears that you may have if your company has been looking at or asking you to look at moving some data to Azure SQL Database, and that our jobs are very much secure, and if nothing else, going to be in more demand.
Well, thank you, Tim. We do have a couple questions here to wrap things up. The first is with the DTU Calculator, can that be downloaded?
Yes. So from the URL that I was on, so it's the dtu.azure websites. Let's go back to that real quick. So click back, so it's dtucalculator.azurewebsites.net. You just click right here, download command line utility. And like I said, it's truly just a PowerShell script. So what it's going to download is this right here. So the SQL-perfmon.ps1. And yes, 100%, and even for elastic databases. So you can measure and get an idea for elastic pooling. So I'm pretty sure this one's going to run for the entire server or something else. I need to dig further into it. But you have both for Azure SQL Database and elastic databases, and those are both PowerShell scripts.
Okay, and then the couple additional ones. So you didn't talk about SSRS from an unsupported perspective, but with the reporting services database that goes with SSRS, can that be hosted in Azure SQL Database?
Oh, great question. What I can do, I do have a virtual machine on my local workstation that I can run the Azure SQL Database advisor against. So if that person wants to email me at tim@sqlskills.com, I'll validate that one for you. But worst case, you would run reporting services on a virtual machine within Azure, the Azure data center. But from a high availability standpoint, I mean, it's still a virtual machine. I mean, have to contend with that. But yeah, I'll have to run the utility against the reporting services and reporting services TempDB and see if you can migrate those to Azure SQL Database.
Yeah, it's a good question. I'd like to think that you could, but you'd have to manhandle it a little bit.
Yeah, that's why I love giving these sessions, because people think of stuff that I have never considered.
All right, and the last question is, if you put a database in SQL Azure, what else is needed to create an OData or REST JSON web service against that database?
Good question. I mean, it's just a data source, and I haven't really played a whole lot with JSON and OData. Again, email me, tim@sqlskills.com. I know all the folks at Microsoft that support this, and I can get answers to that. Very good questions.
All right, that is the last of the questions for today. So with that, we will wrap things up. All right. Well, thanks, Tim. Thanks, everyone who attended. Hopefully, everyone got a lot out of this. I know I got quite a few ideas for blog posts and such, just listening through this. So, thank you very much. Bye, all.
Thank you.